Welcome to the Beyond 3D podcast, where we explore all things 3D and the important role that 3D data plays throughout the manufacturing process, driving decisions throughout a product's lifecycle. Here, we talk with industry analysts, business owners, developers, and industry influencers, and hear real stories that you can relate to and learn from, and know which trends and technologies apply to your business. So join us as we go beyond 3D. Welcome, everybody, to another episode of Beyond 3D. My name is Evangelist, and we're happy to be here again. Today, we will be talking about virtualization. And to join us in that conversation, we have Bastiaan Oud, who is Head of Strategy at SIMCON, based in Germany. Hi, Bastiaan. Welcome.
Hey, good to see everyone.
And we have Jonathan Girroir from TechSoft 3D. Hi, Jonathan. How are you?
Hello, I'm doing fine. Thank you.
And Jonathan, this is the first time that you've actually been on the podcast. So we've had other folks from TechSoft, but this is the first time you're joining us. So could you just take a minute and talk about how long you've been with TechSoft and what your role is?
Yeah, absolutely. So Jonathan Girroir here, and I've been working in 3D graphics, for 20 years now or so. I've been with TechSoft for 13 and kind of been in different roles, different parts of the company over that time. Right now, I am serving as their technical evangelist. My background is software development, but I focus on connecting to our partners, and a real focus of mine right now is building a technical community around our products. But I'm also just interested in anything 3D and business development. So it's a real pleasure to be here with you guys today.
Good. So, Bastiaan, before we jump into the virtualization topic itself, can you just introduce SIMCON and also tell us a little bit about yourself?
Yeah, sure. So hi, I'm Bastiaan, Head of Strategy at SIMCON. And before that, actually, I was at McKinsey Digital, which is management consulting, helping companies shift course, adopt new digital ways of working. And that's also what I do at SIMCON. So at SIMCON, what we do is we help people virtualize their injection molding projects. So we help them take their physical corrections that they otherwise do, in the shape of steel, shaving steel off molds, very expensive, very slow process, and making that digital, so that they have a virtual prototype that they make those changes and improvements in, which saves time and money. And to adopt that type of way of working, you do need to change the way you do stuff in your company, the way you organize time, your people, etc. And so that transfers nicely over from the McKinsey Digital methods that I used before.
Great. And so when it comes to virtualization, you've been doing this for a while. How have you seen things change, let's say in the past year? I mean, we can't ignore the topic of the pandemic, right? So with everything going more virtual, we're talking about virtualization. Have you seen sort of an uptick in accepting this concept and practice?
Yeah, absolutely. I mean, if there's one sort of major effect this has had on the industry is to underscore the value of digitization, right? So people not being able to come in physically to work, if they still want to make progress, they do need those virtual ways of working, digital ways of working. First areas where you can see that is just the way that people work together remotely, but then also just to be able to do their jobs, right? They need a software equivalent so that they can continue their design projects without being on the shop floor. And so that has actually given us a major boost in acceptance and in the speed of adoption that we see in the market.
Yeah, go ahead, Jonathan.
Yeah, so were you seeing actually operational changes in the way in which you interacted with customers over the last, say, year or so, because everybody's at home and the way in which you interacted with them?
Yeah, so definitely. The most obvious place where that changed is in the way we do sales, trainings, and services, right? Those three areas. So where previously in sort of business to business, sales interactions, there was a strong belief really in the market that you do have to have boots on the ground to really make the value of what you do tangible. to build that human connection. We've seen quite a successful transition to actually just doing this via Zoom, much as we're talking now. It also enables you to actually serve more customers more rapidly because you kind of cut out the traveling in between, which is a significant factor in our business, right? Given the fact that our software is not cheap, it's not a casual investment for most of our customers, and so it's worth it to put in a lot of effort and time to really consult the customer well before they make that purchase. And we've seen that actually works remotely quite well. Obviously, establishing new relationships on a human level is easier in person, right? If you can actually have a coffee together physically, that does make a difference. But it's a lot better than doing it on the phone if you do it via video conference. And then same thing in services, right? So we've been, where previously we used to do this essentially by phone and screen sharing. We now actually have video conference plus screen sharing, which people really do appreciate because it gives that extra human connection. I think those are the sort of the major areas where we've sort of really just very quickly switched the way we operate, given the fact that we can't travel.
Yeah. It seems like we shattered some tightly held beliefs over the last year or so, and things didn't stop. So that's good to hear. Mm-hmm. Absolutely, especially for those who pivoted and changed with a new situation.
Yes, and I think that this is one of those examples where it shows that speed of adaptation is absolutely crucial, right? So I think that the pace of change overall, across industries with digital change has accelerated massively, and it's all about adapting to that quickly.
Kind of building on Jonathan's question of how operational changes. Talk about the mindset of some of your customers and perhaps new customers, right? So people are being forced to consider virtualization and other technologies that maybe they had heard about, but just were apprehensive and there was really no need to consider them, right? Yeah. But now they're sort of being thrown into the situation where it's either consider these or go out of business, right? So talk about how that's affected the mindset of your customers, both, the designers and the engineers, but as well as management. Is it top down? I'm just curious as to, are people happy about this change? Have they been a little curmudgeon-y about it? Talk about the mindset a little bit.
Yeah, I think the way that the best way to frame what we do is we bring digital change and we bring new ways of working. And so adopting those does require a shift in mindset quite a bit. I think that the pandemic has helped with making that shift. But the types of shifts that you typically require is switching to more front loading. So it means that the front, like the early stages of your process where you do design, right? They take a little bit longer than they used to, right? Where before it was sort of the race to the first prototype. Now it's like let's invest a little bit more time into doing alignment with the people downstream, with machine settings, who do quality control, who do serial production down the line. Let's involve those guys earlier during design. So it'll cost you a little bit of time early on. But you save that time, 5 or 6-fold downstream, right? And so it's always difficult to get people to sort of make a sacrifice early in order to get a delayed benefit, right? So in order to really get that, you have to paint a very compelling picture of the value that is to be had, right? Because it's less tangible, because it sort of happens later that you get that. And so that's sort of the fundamental issue that management on the customer side need to consider and solve, right? Think of this more of a sort of a change management issue and less of just installing a piece of software and doing a training and you're done. You won't be done, right? You have to convince your people that it's worth it to sort of stick with it, learn how to use this well, change the ways of working, change old habits. And so that is often an underestimated aspect of how much value to actually get from this. Right, the more effectively you bring people on board, the more you sort of pick the first projects you do wisely to have inbuilt. You want to use those first projects as a as lighthouse successes that you can point to in order to sort of rally the troops around this new way of working. Right. And so you need to consider that when you pick those projects and the way you do your sequencing. Better to do one project end to end thoroughly and quickly than stop and show everybody, look, here's what we did. Communicate about here's what the wins actually were. Here's what we learned. Here's what we're going to change the next time around. That's crucial.
So for our audience, we're curious if you could just explain a little bit about the specific area of engineering and manufacturing that you're focusing on, that of injection molding, and then some of the challenges in that area that you're trying to fix with virtualization.
Yeah. So essentially, think of plastic injection molding as you shoot liquid hot plastic into a cavity that is sort of the inverse shape of what you want to build. Right? And you would think that if you want a straight part to pop out of that cavity at the end of it, you would just have that surface also be flat inside that mold, inside that cavity. However, if you build that cavity exactly like the shape you want to pop out of it, that you won't actually get that shape, right? So because as it cools down and solidifies, it shrinks, right? The plastic shrinks during that cooling process. And it doesn't necessarily shrink the same way everywhere, depending on the thermal properties of what you built. And so it sort of shrinks and warps. It twists out of shape. And so in order to get a part that is exactly like you designed it, right, you kind of have to build that mold a little bit wrong to get out a part that's exactly right. And so our software helps with that, right? So it helps you solve these shrinkage and warpage issues by predicting them. Right, and so what you do is you use simulation to understand, okay, if I do these settings, if I build my mold this way, if I build my cooling channels this way, what will the resulting end product look like? How short will my cycle time be? Right, the shorter that cycle time is, the more efficiently you can use your machines, for example. So time is money there as well.
Yeah. So it sounds like. I believe these molds are really expensive, aren't they? Like if you build it wrong, you're wasting money there too, aren't you?
Yes,
and time.
Quite significant, significant amounts of money. So these are often 6-digit sums per mold, right? Depending on the size and complexity of the mold, it's somewhere in the 5-digit to 6-digit range. And so if you get it wrong, you sort of have to go back and correct it in steel, and that's really expensive. That's also often in the thousands to 10,000s. Sometimes even hundreds of thousands to do these corrections. And so sort of getting it right the first time can save you a lot of time. It also saves you a lot of money, right? And so one of these corrections actually can take 4 to 6 weeks. If you're lucky, it'll be done in 2 weeks. So if you do on average, 4 to 6 such corrections per mold, because you're sort of trying things out physically, right, that really delays your time to market and it really costs you a lot of money.
So your software,
the value we provide is cutting that down.
Yeah. So you simulate this in software, allow them to predict what the part is going to be after it cools, try to optimize the cooling process, and then you just build it once and you build it right the first time.
Well, exactly, right? So what we do is we predict the future. So we let you anticipate the results that you're going to have in your manufacturing at a really early design stage. And ideally at a stage where you can still change a lot, right? So once you've sort of cast it into steel, it's really hard and expensive to change stuff virtually. It's just easier to change bits than it is to change steel. And it also enables you to, because you've got these downstream predictions of what's going to happen in manufacturing, have a conversation with the guys from manufacturing earlier. So it enables you to have better conversations there. Mm-hmm. And on top of that, it doesn't just sort of tell you what's going to happen. We also have an automation functionality and optimization functionality to it. So you can sort of use our software to set up not one simulation, but 30 simulations, 90 simulations to test different variants, and then sort of help you pick the best one.
That's fantastic. So you call this virtualization. For our audience, other people might be familiar with digitization. So going from the paper to the digital, and this is happening in many industries. It's happening in the office where let's go digital. But in manufacturing and engineering, it's industry 4.0. It's the whole movement to MBD and model-based design and model-based engineering.
Mm-hmm.
And there are benefits to that, but there's challenges to moving organizations in that direction. And it sounds like you've faced that when you bring these solutions to your customers, that there's a technical benefit to them, but it requires change in the organization and the way in which they do their engineering workflow. So what are some of those challenges, and how have you been able to overcome those?
Yeah, I think the first set of challenges is understanding what the right process even is. Right? What are the changes we need, right? And so, in essence, they're front loading. So you move more of your decisions into the engineering and design phase, so that you sort of have less of a hassle later on. A second one is cross-functional work, right? So you've got people from upstream functions like design working together with downstream functions in decision making during those early stages, right? So it requires more people to be at the table during sort of the major decision gates that you have. When you go from your design to your first prototype, right? That decision, that go, no-go decision, needs to be made cross-functionally. And so it involves getting more people to work together, which is a complex organizational task. And it's iterative, right? So that's the third part. Probably you're not just going to simulate once. You're going to simulate many times. You're going to simulate many variants, right? And so what that means is anything that will help you automate the repetitive aspects of simulation, right? Setting that up in different variants, analyzing results across many simulations, synthesizing those results so that they're ready for discussion and decision making is really valuable, right? So you can focus on sort of managing the parts that only a human can do, which is decision making, really collaborating together, making decisions, getting better outcomes as a result.
Do you have like a customer example? I mean, to kind of illustrate what you've just talked about. And I know you probably can't mention names of companies, which is fine, but anecdotally, do you have an example that you can share that demonstrates maybe it was the first time that the company did a virtualization and the results that they got from that?
Yeah, for example, we work with a large multinational manufacturer in the automotive industry. And so they produce literally hundreds of molds every year, staggering costs. And on average, they had, in terms of physical corrections, 4 to 6 of those per mold. And so that is a staggering amount of money that you sort of put out on the table, given that each of these costs thousands of euros. And so what we did there is we helped them introduce not just simulation, but sort of automated design of experiments and optimization based on those simulations. And they've been able to cut down their the number of correction loops that they do by about 30%. So you don't go from 100 to 0. The reason is you go from 100 to 70% of those correction loops. That's a realistic expectation, which is a lot of money and a really good return on investment.
That's pretty significant.
Yeah, it's quite significant. And so the types of obstacles that you face there are setting up the process the right way. So what's the right process? And then getting that done organizationally, right? So bringing your people on board, actually training the people, picking your first projects. Where am I going to do this? Learning to sort of work in this new way, which is different and requires different types of decision-making along the way. And so we help with that. So we have... We don't just see ourselves as a software vendor. We do see ourselves also, so it's SIMCON, right? Simulation and consulting. So that's the second half of what we do. So we help our customers with that. We help management think through, how do I set this up, right? How do I sequence my transition? How do I go from a pilot to scale so that it becomes sort of the new normal way of working?
Do you think that if you didn't have that consulting side to manage change at the organizations, you wouldn't be successful?
Well, I think it is possible, given the amount of value that's just in sort of using the software, that it would be possible to sustain a business, but I think it would be less effective, and that the customer would get less ultimate value from it, right? So it would be sort of enough value to sort of justify the investment, but it wouldn't really be milking it. You wouldn't really be getting the maximum out of it that you can, right? And I think ultimately that's what we want, right? We want our customers to benefit from the software so that they continue to use it, and really, improve the way that the industry works.
Yeah. Can we talk about data flow for just a second? I'm really curious where
Sure.
you have in the engineering design process and the life cycle of engineering design, you have ideation, then you have design in CAD, and then you go to manufacturing. So there's the step normally in subtractive manufacturing, you have CAD CAM. That's because even in CAM, you have to kind of reverse, you have to rethink the part. Then you go to manufacturing, and then you go to quality control, and then maintenance. You sit in there kind of in that, I'd say CAM spot, but there's also analysis. What we see is analysis feeding back to the design process and getting affecting design decisions. And is that where you see it? And we have to influence decisions kind of upstream when data is flowing. And so we have this kind of circular workflow of iteration and process iteration and engineering design iteration. Is that where you sit?
So we actually sit in multiple places there. So people already use us, when they're doing sales to sort of cost their projects appropriately before they actually do the real design. They do sort of a quick and dirty version to sort of make sure they don't make any obvious mistakes early on. Then they use us again during design, during the engineering phase, where they try to involve the downstream people to make sure they don't make bad decisions there. Then during actual sampling, right? So sort of the part that you just mentioned and labeled as manufacturing is like this whole chain of events, right? So there's like, you design the part, you design the mold, you design the process parameters that you're going to use in manufacturing simultaneously, ideally, so that you can sort of use one to inform the other. And then you build an actual physical mold and test it, right? So you do sampling. During that stage, we also use our software to do sort of root cause analysis if something doesn't turn up as expected, right? So it allows you, by having sort of varied many parameters during using simulation, you understand what are the parameters that could be off, and if I twist, if I pull this lever, what's going to change in the result. So if you see errors, you know what to do in order to correct them. But because otherwise, all you see is like, oh, something went wrong. Now what do I do, right? So it's used there, and then finally, it's also used in quality control. We actually have a collaboration with a company called Volume Graphics who do industrial CT scanning, and their software is compatible with ours. You can actually use the same quality measures that they use in their software in our software to do the virtual optimization. So you can link those two things, the way you do quality control and the way you do optimization earlier on, so that you can also learn across time sort of what works, what doesn't work, and you have a consistent language for control across the entire sort of for quality across the entire process.
Yeah, it sounds like
that is a recurring theme, where quality means a different thing early than it does in the end, and then a lot of sort of decisions get sort of lost in translation in these stages, right? Engineering has one idea of what does good mean, what does success mean, than manufacturing, and you get some tension, some friction there. You can get that under control by having these upstream cross-functional teams decide on what quality means together, and then using consistent quality measures through your entire process.
So it really sounds like with Volume Graphics and other kind of parts of this process, interoperability, both from a technical side, is very, very important, because you're influencing design from things that are being analyzed downstream. Being able to also have interoperability between teams is important. So this whole process is would you say it's getting tighter and more efficient?
So I would say that ultimately it needs to be end-to-end integrated, right? Mm-hmm. So the idea is sort of maximize the end-to-endiness, if I can make that an adjective, of what you're doing. That's true in terms of process, where you want sort of downstream to be involved upstream, it also means you need to reflect that in your systems and software landscape, right? You want the parts of the chain that you're using there, your CAD and your simulation optimization and your quality control later on, and whatever system you use to steer the machines that you're using during manufacturing. You want those things to be able to talk to each other and sort of play nicely with each other. And ideally, actually, I think that if I were looking at this from the customer perspective, what I'd aim for is not just purely interoperability of the particular tools you're using right now, but their compatibility to open standards. The reason is, if they're not compatible to open standards and the connections between them are proprietary, it'll be really hard to switch out particular parts of that chain, right? Each element of the chain will make other parts of the chain sticky. It's like a puzzle, right? Where you take out one piece and then you say, I want to put something different in, and it just kind of won't fit, right? And in that same way, I think that if you kind of standardize the outside shape, the way it connects to other stuff, right? It'll make you more flexible as a customer. It'll make it easier for you to benefit from wherever the fastest technological progress is happening in the future, which you cannot anticipate now, right? So aim for open standards, aim for interoperability. I think those are the types of things you would aim for as a customer.
Do you see one standard? I mean, you're in automotive, being there in Germany. Do you see one standard kind of rising to the top, or is it still lacking in our industry?
I think it's still lacking in the industry. So there are some first attempts at this. For example, there's VMAP, which is actually a publicly funded standardization initiative here in Europe for CAX software, which we are compatible with. However, I wouldn't say that there is already an established coordination of the market on any individual standard. Right, so I think that is something. If you look at the dynamics of a market for standardization, the best incentives for making that happen are actually on the customer side, right? So I would recommend to any customer, ask for standardization, because you are in the best position to make this happen. If you look at any individual software vendor, the incentives are not like that, right? The incentives are actually that you want to make sure that you have recurring revenue, et cetera, et cetera. So it's going to be difficult to ask the individual players in the market to do this on their own without customers strongly pulling for it.
Yeah, and they want to keep their data with them, right? That's right. a business decision where we don't want to have and each organization is different, but we want to keep it sacred to our ecosystem, and not be pushing it out there. And that's one of the things we're trying to work on, is break down those walls.
Yes,
and either push standards or provide tools that allow you to bring in whatever data sources is available to you.
Exactly. And so just sustain flexibility, avoid lock-in, because it's you just won't have the prescience to know what technology you might need in 5 years' time, right? And so you need to set up, as a customer, as a manufacturer, you need to make sure that you set up your system for interoperability, flexibility, and the ability to switch out particular parts of your digital chain later on as technology evolves.
Yeah, that's a great point. So we are coming up on our time, but there was one other thing that I think we wanted to touch on, which is sustainability. And then as we wrap it up, would love to get your advice to anyone out there that is considering virtualization, or maybe they've tried it and had a bad experience. I don't know, but what would be your tips on what's the first step? How do I get started? If I'm evaluating a vendor, what should I consider? That sort of thing. But let's address sustainability.
Yeah.
And
so overall, sustainability is probably the most important megatrend that is facing the plastics industry at this time, both in terms of consumer perception in the market, rightfully so, as well as in terms of resulting from that regulation that is already coming now and will come with added force in the future. And so I think that if you're a manufacturer and you don't have this on your strategic agenda, that's a grave mistake. So this should be top of mind for management everywhere. Now, how do you operationalize that and become more sustainable? I think the first thing is you need to think about hard about, what are the right metrics for sustainability, right? How do I even quantify this so that I can treat it as an engineering goal? And then secondly, you need to think about how do I operationalize evaluating on those metrics, right? So for example, let's say that you want to increase the share of materials that you use that don't come from petrochemicals, that use feedstock that is biological and sustainably regrown in your production. Now, one of the things you need to figure out is, if I use this other material, what will the properties of that material be in manufacturing? What can I actually substitute for what? What design changes might I need to make to have the same functional properties with a different material? Right, and so by using simulation software, you can figure that out, because you can actually try it virtually before you do it physically. And to realize that, you need to trade off multiple goals that you have at the same time. And so you need software that is able to trade those off against each other, right? Because you will not be able to sort of intuit what will the manufacturing consequences be. Right, and so simulation tells you exactly that, right? So it tells you, if I use this material, what will happen? What do I need to change to get the same functional properties? What might my energy use be? How thin can I afford to make the walls of my part without it, becoming fragile, so that I don't waste material? How can I build, my gating system, through which the liquid plastic flows before it enters the cavity? That part of the last bit of that essentially is waste. Because it's, as it solidifies, you can no longer use it for the next part that's also ejected. How do I minimize that waste? All of these things are ultimately engineering design decisions, and so the information you need to make those choices should be available at the time of engineering decision making, and so they should be in the software that you use, as you are doing your designs.
That's a great way to sort of wrap things up, and let's just get to the advice for anyone considering virtualization and how to get started. What would be some of the things that you would advise?
So I think the key piece of advice is start with the value, right? So start with understanding, where do I want the value to come from in my company? Where will the savings actually come from? Where will the benefits come from? Where will the gains come from? Once you've got clarity on that, right, it'll help you understand, what should my process look like that I want to have in the future? And then only should you pick the software that you're going to use and in that process, right? So your software landscape should fit your process, and your process should aim to get value. So if you do it the other way around and you sort of make your process fit your software, it's really likely that you're not going to maximize value, right? So conceptually, what that means is, management needs to think hard about what they want the future to look like, where their gains should come from, and then work from there, and not the other way around. It also means that once you've sort of picked what best fits into your planned process of the future, you should really think about change management. You should think hard about change management. How are you going to sequence it? Start narrow but deep, usually is the advice that we give, right? So aim for really quick wins, lighthouse successes that you can point to. Better to do one project really well and then talk about it a lot than to do 10 projects sort of meh, right? Because then you're not going to have anything to point to, and this is how progress dies, right? It's like, that's how you lose momentum. You've stretched thin, and now people were like, well, 6 months later, we haven't seen any successes.
Right.
Let's take away funding. So it's better to do sort of one thing fast but really well, then scale from there, because now you've got something tangible to point to along the way.
Very, very sound advice. Jonathan, anything you want to add as we wrap it up?
No, it was a real pleasure meeting you, and thank you so much for your time today.
Thanks for having me.
Yeah, thank you both. It was a great conversation. Hopefully our listeners found some inspiration and learned a few things. And we'll put a link to SIMCON in the comments or in the show notes. And so thank you again, both Bastiaan and Jonathan. Thanks to our listeners. And for those who haven't subscribed yet, please hit the subscribe button and share this podcast with your colleagues or anyone that you think might be interested in these types of topics around industry and 3D and virtualization, digitization, as we are pushed more into a digital world. And if you have a minute, please leave us a review on iTunes. It will help others find our podcast and join our conversation. And with that, we'll just say thanks again and have a wonderful day. Thank you.
Have a good one, everyone. Bye-bye.
Thank you for joining us on the Beyond 3D podcast, hosted by TechSoft 3D. Be sure to subscribe on iTunes and leave us a review, or subscribe on SoundCloud. To listen to past episodes or learn more about TechSoft 3D, visit www.techsoft3d.com/blog. Send us comments and suggestions at info@techsoft3d.com. Thanks again for listening, and we hope you'll join us again on the next episode of Beyond 3D.